Today's topic is encrypting sensitive data in the e-business suite. And we're going to walk through all the different sensitive data elements you might have in your environment, things like social security numbers, credit card numbers, bank account numbers, etc., and talk about how to encrypt those numbers and other sensitive data elements. This is more of a topic that is in a broader context of protecting sensitive data. So we've done previous webinars talking about protecting sensitive data in the e-business suite. This is really more of a deep dive. So now that we're hopefully protecting it a little bit, doing access controls auditing, we're now going to delve into how to actually encrypt some of these elements. This is one of those topics in the e-business suite that's not easy. There is no silver bullet solution. There's nothing that covers everything easily at zero cost. There's a lot of trade-offs here. Some products work, some products don't that are available on the market. Some cost a lot of money. So they're probably walking away at the end of this presentation. You'll say, well, at least have a better idea what I can do, what I can't do, what works. But you're probably not going to walk away saying, oh yeah, this is easy. I'm going to go flip the switch and say encrypt all data, be super secure. There is no profile option in the e-business suite that does that. So we're going to walk through the different options and kind of give you an idea of what you should be doing, where are some of the pitfalls, and at least give you a better idea on how you can approach this problem. So before we get started, a little background about Integrigy. Integrigy was founded in 2001. We specialize in e-business suite security. So we do security for both ERP applications like e-business suite and also databases like Oracle and Microsoft SQL Server. We have two different sides of our business. One, we have a set of products, one being AppSentry that basically helps validate the security of your e-business suite environment. And then also AppDefend, which is an application firewall for e-business suite. So if you're running iStore, iSupplier on the internet, it provides another layer of security. What's more relevant to today's discussion is our services business in terms of providing on-site security assessments and security design services. So a lot of the presentation today will be based off of what we offer in terms of services and how we've worked with a number of clients to help encrypt their data. So this is based on real-life experience working with many different clients today on how they tried to tackle these problems, how some succeeded, some didn't succeed. Probably those who didn't succeed is more important because there's a lot of pitfalls and challenges in trying to encrypt your data. So enough about Integrigy. Let's talk about encrypting sensitive data. First, we'll start with a little bit of overview on sensitive data. What are we talking about? What are the data elements? What are some of the challenges there? And then we'll actually talk about the different encryption options available within the Oracle e-business suite. This presentation is very specific to the Oracle e-business suite. If you have just a generic Oracle database that might be a data warehouse, you have actually a lot more options in encrypting the data in that type of environment than you do for e-business suite. E-business suite is a very complex, large database, many views, many triggers, many materialized views. So there's a lot of different things going on in the e-business suite that preclude some of the standard options. You can't just go in and start changing Oracle e-business suite native code to add some encryption layers if you want. So we'll kind of talk about what's supported, what works primarily throughout this presentation. So let's first talk about sensitive data and what is sensitive data and why do you need to actually encrypt it. There's really three main drivers that we see for most of our clients when they start talking about sensitive data and why they want to encrypt it. The first and foremost one is PCI, the Payment Card Industry Data Security Standard. So requirement 3.4 of PCI DSS says you must encrypt credit card numbers. They recommend you encrypt some of the other values, but really the only mandatory piece is the actual credit card number. As part of the PCI standard, they call it the primary account number or the PAN. And it's a pretty rigid standard. So if you're accepting credit cards as part of your business and storing them or processing them in the Oracle e-business suite, you have to be encrypting that data. The second main driver is privacy laws. The privacy laws are mostly done by the state. So the first one is really California's SB 1386. Massachusetts has a pretty good one, and a number of other states have privacy laws. If you're working with the European Union, the European Union has very strict privacy laws also. And so it really is a hodgepodge. You really need to work with your legal counsel and try to identify how these different laws affect you and what are some of the issues you need to address. But basically, at the end of the day, most of the privacy laws require that you actually notify people in case of a breach. And a breach would be considered first name, last name, and some sort of account number. However, a number of the regulations actually exclude encrypted data. So if you can prove that the data was encrypted when it was stolen, So let's say, as an example, you're encrypting your backup tape. The backup tape falls off the back of the truck on the way to the storage. You basically don't have to do a notification. That's really why encryption comes into play with the privacy laws. And then finally, HIPAA. So if you are storing some sort of HIPAA data, so this is basically protected health information. So you're storing health information on customers, other people, on your employees. There's certain regulations within HIPAA that really recommend you encrypt the data. These are addressable implementation specifications, so therefore consider them type of optional, but you need to have some sort of compensating controls if you aren't encrypting the data. Within HIPAA, there's also breach regulations, just like the privacy laws, that say if the data is encrypted, you don't have to actually notify people. We have a few customers who are actually medical device manufacturers, and they actually have all their accounts receivable is actually HIPAA data, because if someone buys directly from them, buys a medical device or a part to a medical device, maybe some just consumables and things like that, that's considered HIPAA data. So they actually have to encrypt a significant amount of their AR data. And so it's kind of interesting on the HIPAA regulations what comes into play. For most Oracle eBusiness Suite customers, the HR data falls under the HIPAA depending on what they're storing within the eBusiness Suite. So those are the main drivers. So when we start now talking about what is sensitive data in the eBusiness Suite, we're talking really about three different categories of data. The first is, again, the payment card industry, the data security standard relating to credit card numbers. And for the credit card numbers, you're really looking at the actual credit card number. The other key element for PCI is the 3-digit code on the back. So when you actually go on to Amazon.com and put in your credit card number, you actually have to put in a 3-digit code from the back. On the Amex, it's the 4 digits on the front above the number. That's actually also very sensitive data. You should not actually be storing that in your eBusiness Suite environment. So during most of this presentation, we'll talk about the credit card number. Magnetic stripe data is also pretty sensitive data in Oracle eBusiness Suite environment, but it's very rare that you're actually storing it. You're typically, if someone's swiping a credit card number, that's being handled at a point-of-sale environment and not actually transferred in the eBusiness Suite. For the privacy regulations, this is where things get a little bit trickier because PCI is very nice. It's very specific. It tells you exactly what you need to protect. Now when you start talking about some of these other regulations, they're a little bit more open-ended. When we talk about privacy regulations, we're typically talking about first name and last name in some sort of account identifier. Some of the regulations are more specific where they talk about social security numbers, driver's license numbers, financial account numbers. Others are basically a financial account number. So what is a financial account number? That can be a lot of different things. Primarily bank account number would come under that, but do other types of numbers and information come under that. For privacy regulations, also one of the key ones is social security number. Well, obviously for your employees and HR data, that's a social security number. That probably has to be protected. For your customers, you may be storing some social security numbers. If you're doing any sort of credit checks and things like that, you might be actually obtaining your customer social security numbers. Vendors are an interesting example because you may be having people who are providing you their tax ID as a social security number. So if you actually are hiring independent consultants and putting those people into your accounts payable system, you're probably generating 1099s for them and they're actually supplying your social security number. Typically for your vendor, if it's a corporation, they'd have a federal tax ID number, FEIN. That's not protected. That's actually public information. So you may have 10,000 vendors. You may have a couple hundred vendors who are actually social security numbers because they may be just a private partnership that's not incorporated and things like that, and they'll actually give you a social security number. So does that come under the privacy regulations? And in most states, the answer is yes. And then finally, when we just start talking about HIPAA, protected health information is a lot of different things. So it's anything that is past, present, or future about a medical health condition, provisions of healthcare. So if you're providing any sort of healthcare to someone. So HIPAA is a little bit broader. So if you are providing some sort of healthcare services, products, etc., that becomes a lot more complicated in eBusiness Suite environment. We'll kind of touch base a little bit on HIPAA throughout this, but we're really going to concentrate on the major identifiers like social security numbers, credit card numbers, bank account numbers throughout most of this webinar. And that's what most people are concerned about, and that's kind of, if you do a first pass, that's kind of what's important. So that's kind of what are the sensitive data elements in e-business suite. So now the question is, where is that data stored? And this really becomes a challenge in the e-business suite environment. The data is not centralized. Oracle e-business suite, the data model is somewhat close to 25 years old plus. So it's a very old data model. No one 25 years ago was thinking about, oh, Social Security numbers, we need to protect those, and we have to have those all in one table that can be easily protected and encrypted. No, as time went along, people said, okay, new module, we're going to accept credit card data in this module, so we have to store it. So when you look at the Oracle e-business suite data model for like credit cards, only recently did they start storing in one table. Previously, well, AP needed credit cards, order entry needed credit cards, Oracle contracts needed credit cards. So those module development teams said, oh, we have to accept credit cards, so we'll just throw it in this table here. So data is scattered throughout the e-business suite for sensitive data elements that is not concentrated in a few tables. You may have it in 10 or 20 tables. We recently did a sensitive data search for one of our clients, and we actually got about 250 different hits on these different data elements here. So there's 250 different tables that they were actually storing some form of bank account numbers, Social Security numbers, credit card numbers in different tables. A lot of those were custom tables, a lot were backup tables, but the data gets scattered to the wind in the e-business suite environment. So this is just an example of the standard tables. There's actually more. We actually find it in many different fields when we do our sensitive data searches. And until you actually have some sort of tool that can crawl through the database, it's very hard to detect. Because if you store it in a flex field, the flex field column name is not going to be Social Security number. It'll be attribute 1 or something like that. So those are kind of the standard tables for e-business suite where sensitive data may be stored. Sensitive data may be stored in quite a few different places in an e-business suite environment as a whole. So just in the database, there's 4 other locations. You may have custom tables. Probably about half of the tables that we find when we do a sensitive data search are actually custom tables. So you have some interface, some process running that you're taking the credit card numbers or Social Security numbers and moving them around and processing them. A classic case is for order entry. Most people don't actually accept the credit card numbers in order entry within e-business suite. What you do is have some other e-commerce system that then passes it in, so you've actually got a custom table that you're passing it into, and then you process it, put it in the interface table, and then actually load it into the order management tables. So those custom tables typically have the credit card numbers. Another classic one is the maintenance tables. Any DBA worth their salt, first thing they'll do is when one of the functional people comes up and says, well, we need to do a direct table update to the all people F table. The first thing the DBA is going to do is, before he does that direct SQL update, is do a create table as select and actually do a backup of that table. Then what happens is, after they've done the backup of the table, they go back to the functional person and say, okay, go test that, and then we'll make sure it works and everything. Person comes back, the functional team person comes back a week later and says, okay, yep, it worked. Typically the DBA forgets to actually go drop that backup table. And they sometimes will say, oh, I don't really want to drop it just in case in 2 months they found out there was a problem. So at least I have that data backed up. Because it's much easier to pull it from a backup table that's live in the database than from a backup tape, and having to restore that becomes fairly complicated. But at least now I have the data there. So we'll find maybe 25% of the tables when we do a sensitive data search that are actually these backup tables. They're very common, especially for the key tables that Oracle support asks you to do direct table updates. One case we just did recently was HR all people F table. We found 12 backup copies of it. Just over time, and no one dropped those. So when you're now doing cloning and things, those backup tables are going to your development and test environments. You're probably missing scrambling them. You're probably missing actually doing encryption on those tables, because you did, hopefully, after you're done with this presentation, you go through and encrypt the data correctly, but you may not be encrypting those tables. Another spot is interface tables. Sometimes transactions get stuck in interface tables, so that tends to be a problem. Occasionally, we'll find flex fields that people basically are putting credit card numbers, Social Security numbers into flex fields. That may be based on a data conversion issue. When you're doing the data conversion, you start populating a flex field with a Social Security number. It's very hard to find those. So outside of the database, you also might have log files and interface files that have Social Security numbers and credit card numbers, bank account numbers, as you're transferring those numbers from other systems. So you may keep a backup copy of every single interface file that comes in. All those files have sensitive data that can be accessed. Someone can steal that data pretty readily. And typically they are not encrypted when they're transferred from system to system. Log files, it's very easy to turn on logging within Oracle Payments, especially in 11i, that then you write out all the credit card numbers. I can't tell you how many times we find debugging enabled for Oracle Payments in different EBS environments. That's a very common thing to do because someone says, oh, we have a problem, they enable it, but they always forget to turn it off, and then you've got a massive log file that includes all the credit card numbers. So data is basically in many different locations within the e-business suite. And when we talk about encryption, we really want to make sure you're thinking about this in a larger perspective. It's great to just basically, let's go turn on encryption. It's not that simple. You need to think about it as part of a data protection process. So the methodology Integrigy uses is kind of a 5-step methodology. So we start off looking at your enterprise data privacy policy. And from that, we actually develop a very detailed Oracle e-business suite data protection policy. And this goes down to the data element level. And so when we talk about Social Security numbers, we're not just talking about employee Social Security numbers. You might have vendor Social Security numbers. You might have customer Social Security numbers. And what you do with each of those should be considered a different data element because it's not just Social Security numbers. So your privacy policy may, well, we need to protect Social Security numbers. Well, is that privacy policy thinking about employee numbers? Is it talking about 1099 numbers? In each of those data elements, you might have to do something different. Then the second step is basically taking that data protection policy and kind of doing a design, saying, okay, when we encrypt this information, how are we going to encrypt it? Are we going to have additional access controls? Are we going to have additional auditing? And then you also do a data discovery, so you actually go through the entire database using some sort of tool or a whole bunch of queries and try to figure out exactly what tables and columns those values are. And then from that inventory, you're actually then saying, okay, for this specific table and column, I'm actually going to do this action. It may be encryption, it may be additional auditing, it may be access controls, it may be scrambling and test and development. And then the third step is basically going through and taking each of those tables and columns and trying to do something with it. There may be cases where you actually cannot encrypt something. You actually have to put additional access controls. And the fourth step is when you're talking about test and development. I now have to scramble all those values when they go down to a test and development environment. The developers may start screaming saying, well, I need to have referential integrity and I have to have actually a valid number. And so you have to work through those issues. Then finally, the context of trying to protect the data is really, you have to look at all security within the environment. It's great to actually have encryption, but if you have the apps password set to apps, the encryption is not going to do you much good because that apps account needs to have access to the unencrypted values. So unless you've hardened in the environment and make sure people can't get in behind the scenes on changing the apps password, changing all 250 Oracle database, e-business suite database account passwords, applying security patches on a regular basis, not letting developers into production. So this is basically a whole process that you have to go through in order to protect the data. So today's presentation is really going to focus on the remainder of the presentation is going to look at encryption. So we're going to go through the different options to encrypt data in the e-business suite for the rest of the presentation. So let's kind of reset what we talk about and what we mean when we say encryption. There's basically three different types of encryption. There's storage encryption, and that's usually referred to as data at rest. So when the data is actually sitting on the disk, the storage medium, and the storage medium might be a backup tape, it might be a USB key, it might be a physical hard drive. Is that data encrypted? The second type of encryption is network or data in motion. So when I'm transferring data between two systems and it's going across the network, is that value encrypted? Some people take this definition and say, okay, if it's in a log file when it's being transferred also. But basically, we'll talk about network encryption here. So when I'm transferring across the network, it may be my intranet, it may be the internet, is that value encrypted? So if someone can intercept that communication, can they actually read the data? The final definition is one that's becoming more common, and it's really called data in use or access encryption. Is the encryption providing value in terms of access controls? So when I try to read the data based on my user ID, my roles and responsibilities, is the value encrypted or unencrypted? And so this is now starting to enforce some segregation duties, only letting a subset of your users actually see the data. And we'll talk about all three of these in terms of Oracle E-Business Suite and when they each come into play. So at a high level, there's a couple different possibilities of encrypting data when we're talking about storage and access encryption. So if you look at it, you can break it down into three different categories: application, database, and disk and storage. When we talk about encryption, application encryption is the best. This means the application is actually responsible for encrypting the data, and then I can have very strict access controls down to the individual application user or even responsibility. And mostly in Oracle E-Business Suite, it'll be at the responsibility level. Oracle E-Business Suite has native application encryption for a limited set of columns. They've developed a technology within the E-Business Suite called FND Vault. So Oracle E-Business Suite can encrypt values, but it's only limited to a couple of values. But you can also use what Oracle has created in terms of FND Vault to encrypt some of your customizations. So our recommendation is always, whenever possible, implement application-level encryption. That's using the native EBS encryption, and then for your customizations, actually including in encryption capabilities when you write a customization. When you write the customization, this does require, every time you read and write that data in the interface programs, other customizations, you're actually calling encryption and decryption code. And then you can actually use the Oracle FND Vault to do that. And there's some examples on MetaLink that you can use. Another option is for the database level is view trigger encryption. This is kind of an elegant solution to allow encryption and decryption without actually changing the way the application works. And so basically the way the view trigger encryption works is you put a view on top of the table, and so when someone accesses the view, they actually have a capability within the view, because it's calling a procedure or something to actually decrypt the data based on some access requirement that may be the database account. You could actually do it with responsibilities too. And then when you write the data, you actually call the trigger. So you call the insert update trigger, and it actually writes the data to the database encrypted. Some customers have actually tried this with eBusiness Suite and putting view and triggers on standard tables. It becomes a mess at the end of the day and doesn't really work. So we really only recommend the view trigger encryption for customizations. But if you have a large number of customizations and you want to very quickly add in encryption, doing view trigger encryption actually works fairly well. There's actually sample code on MetaLink to do this using the FND Vault. Then finally, the third option is using disk storage encryption. So the first two options are actually working within the database, and I can provide some access control within the database, and I can use responsibilities, application accounts, database roles to control what's encrypted and who can access that unencrypted data. The third option, disk storage encryption, works at the database level. So as long as the database is open and running, what I see is unencrypted data. So once I sign on to the database, the data is unencrypted. However, when it's written to disk, it is encrypted. So if someone steals a database file, steals a backup tape, the data will be encrypted. So it's not as good as application level or database encryption because once someone signs in, if I have access to that data, I can see it unencrypted. There's no other additional layer of responsibilities or anything like that. So the key solution is Oracle Transparent Data Encryption. Many Oracle eBusiness Suite customers run Oracle TDE. It works fairly well. But you do have to understand it's not a complete super solution. Application level encryption is the first choice, and then I would always fall back to transparent data encryption. If transparent data encryption is too expensive for your wallet, there are other third-party solutions. Most Oracle eBusiness Suite customers rely on Oracle TDE because it works so well with the database. It's transparent, nothing's required to be changed. You just work with your Oracle wallet. But there are a number of disk-level encryption solutions. There's a third-party product. The one we're most familiar with is Metric. It works fine with Oracle eBusiness Suite. So those are kind of the solutions at the disk level. And we'll kind of talk about each of these in a little bit more detail as we go through the presentation. Those are the access and storage level encryption solutions. The other type of encryption that we need to talk about is network level encryption. So this is basically when I'm sending data to and from different pieces in the environment. So when the user is actually talking to the application server, this is the user's browser connects to the application server, and this is just the same thing as you're talking to your bank. There's SSL encryption, that basically the information being sent across the network can be encrypted. And your bank almost always uses SSL encryption. Using with eBusiness Suite as a default is an optional setup. And we'll kind of talk through the different ways to do that. The other level of encryption is between the application server and the database server. So this is the SQLnet traffic that sends the SQL commands to the database server, and then the database server responds with the data. All that traffic by default is not encrypted. So you can actually encrypt that data. That's probably the lower risk one. The higher risk item is actually when the user's browser is talking to the application server, because that's traversing a much larger portion of your network. Hopefully your application server and database server are right next to each other in the data center, and there's not many opportunities for someone to actually sniff that data, put in some nefarious device in to actually capture all that traffic. So those are the different types of encryption. We'll kind of go through some of those in more detail. First, let's talk about the different sensitive data elements in eBusiness Suite. For the rest of the presentation, we'll talk about the big three: credit card numbers, social security numbers, and bank account numbers. These are really the data elements we see most people really trying to tackle when they start talking about encryption in eBusiness Suite. There's many other data elements: first name, last name, address, date of birth, driver's license number. There's a lot of different things within the eBusiness Suite. Our recommendation is typically for people to really start addressing the big three, because if you can at least get started with these elements, it's much easier. It's a much smaller scope. You can find them easily within the database. They match very easily with regular expression patterns. The locations are fairly well known. And so if you try to tackle these big three data elements first in terms of your encryption project, you'll be much more successful. And then once you've kind of tackled these, then you can look in the future and say, okay, let's expand this out. We understand how this works. Our scrambling scripts are working. Now it's just expanding what we're doing versus trying to do everything at once, and that becomes a much harder project. So when we talk about each element, though, you have to also remember that when I talk about credit card numbers, there's multiple types of credit card numbers within the eBusiness Suite. So for credit card numbers, most likely I'm using order management. I've got my customers' credit card numbers. But however, I might also have employee corporate credit card numbers. So these are the credit cards that are issued to the employees. Those are stored in a different location with the eBusiness Suite. Fortunately for PCI, anyone having to deal with PCI compliance, a lot of organizations say, oh, I've got employee corporate credit cards, I have to be PCI compliant. You can actually get a waiver from having to be PCI compliant for employee credit card numbers. Your customer credit card numbers always have to be encrypted, but employee credit card numbers do not have to be encrypted under PCI. There's a lot of misnomers out there regarding that. So if someone's talking about having to encrypt employee credit card numbers, you don't have to do that under PCI. When we talk about social security numbers, social security numbers are in different areas. So I most likely have employees if I'm using HR. That's pretty common. A lot of HR implementations have social security numbers in multiple locations. But I also might be talking about accounts payable. So again, when we talk about our vendors, if the vendor is using their social security number as a tax ID, those will be in AP. Those are in separate tables. Customers, I might be capturing customer social security numbers to do credit checks and other things. For bank account numbers, I actually typically have three different types of bank account numbers. Well, I've got the company bank account number. I've got employee bank account numbers for doing direct deposits. And then I've got vendor bank account numbers to do EFT payments typically. When we start talking about the native eBusiness Suite encryption, only a few of these values are covered. So when we talk about each different data element, we have probably a different solution for each one. So we're talking about doing different things for different ones. And if they're stored in standard tables or custom tables, I'm probably going to do something different. So there's not one silver bullet here. I'm not just going to walk in and say, well, I'm going to encrypt it this way for all these different elements, and it's going to work the same way for everything. Unfortunately, that's not the way it works today in eBusiness Suite, and probably never will. It's a very complex application. Application-level encryption is very difficult to implement. It took Oracle 3 years to do it just for credit card numbers. They're probably not going to do it for social security numbers. So basically there's a couple different options, and we'll talk about EBS native encryption first. This is our recommended solution, and so if you're running bank account numbers or credit card numbers in eBusiness Suite, you really need to look at the native encryption. So back in 2006, Oracle released native application level encryption for a limited set of fields. The key thing here is in both 11i and R12, Oracle does not enable this. So if you just installed first time Oracle eBusiness Suite 12.1 and started accepting credit card numbers, those are not encrypted. So Oracle does not enable any encryption by default. It's all basically on you to basically walk through and have it set up and enabled. The native encryption within the eBusiness Suite is a significantly better solution than using TDE. A lot of customers look at saying, oh yeah, we'll just implement TDE. To protect credit card numbers, we highly recommend you use the native encryption instead of TDE. You can also use TDE for a second level encryption, but TDE doesn't provide any protection if someone signs onto the database. So this is every single time the application reads and writes the data, it's encrypting and decrypting, and actually has protection so no one can decrypt that data unless they're signed into the apps account. So it's pretty powerful. It works fairly well. The big problem, though, is it only covers several elements. So if you're running 11i, the native credit card encryption only does customer credit card numbers. It will not do the employee corporate card numbers. In R12, because Oracle rewrote the payments module, so Oracle Payments is a basically rewrite module within R12, they've expanded what's encrypted using the native encryption. So not only does R12 do customer credit card numbers, it does the employee credit card numbers, and also does vendor bank account numbers. But it does not do your HR bank account numbers. So that's kind of a gap. So you've got your employee bank account numbers, and it's always a nice trick if you want to do some fraud is you just go update everyone's bank account numbers within HR, and then all the direct deposits will go into a single bank account number. You can get a couple $1 million. Fairly easy to track, but that's fraud. You hear about those type of things happen occasionally. So the EBS native encryption is different for 11i and R12 because they rewrote the Oracle Payments module. Within 11i, the keys are stored in the database. It's limited to just credit card numbers. And to implement it, unless you're running 11.5.10.2, you can do it for 11.5.9, 11.5.10, 11.5.10.2. There are some pretty significant prerequisites prior to 11.5.10.2. So that's just something to keep in mind when you're implementing it. You might as well at that point upgrade to 11.5.10.2. For R12, Oracle's improved the encryption process. They actually store the encryption keys now in the Oracle wallet. Because the problem is if you take your encryption keys and store it in the database and you back up the database and someone steals your database, well, they've got the encryption keys and the encrypted data. The key for R12 now is the encryption keys are in the Oracle wallet, so one of the decision points you have to make and processes you have to develop when you start talking about encryption is now I've got the Oracle wallet. I have to actually back up the Oracle wallet in a different location than I'm backing up my database files to make sure that those two things aren't together. And the problem is if I lose my Oracle wallet at any point, I can never recover the data. So you always have to make sure you have a very robust backup of your Oracle wallet that's stored separately from the database. And the same thing applies for Oracle TDE because it uses the Oracle wallet. The native encryption works well. It provides a very strong level of protection. The one key, though, is it moves data around. When you enable it and it starts storing all the data within IBUI security segments table instead of using the standard module tables. You also have to run some concurrent manager programs when you enable it to actually move the old credit card numbers, old bank account numbers from the standard tables into IBUI security segments. So the enabling of the native encryption does take a couple steps. You actually have to enable it, set up keys, but then you actually have to run concurrent manager programs to move the data. And there's a couple other options. So you do have to be careful when you enable the options because you can actually set it so it encrypts the data later instead of immediately. You want to make sure that's enabled to immediate. So it is a couple of step process to actually get it enabled and working. And then you actually should be going back after the fact. Oracle doesn't provide any routines or anything or SQL to do this, but you need to go check those tables that were storing credit cards because we found in numerous occasions the concurrent manager programs do not migrate all the data. So you might have 1 million orders in your OE order headers all table. What we find is it may have moved 900,000 credit card numbers instead of 1 million, and 100,000 for some reason weren't moved. So you always have to make sure you go behind the scenes and check that all the data got moved appropriately and there's no extraneous credit card numbers laying around. A few of the challenges that we found with the native encryption is you do have to remember to rotate the keys. So Oracle PCI, if you are accepting credit card numbers, requires you to rotate your keys, have dual controls of keys and things like that. So you have to make sure you follow the key procedures. The most significant challenge for PCI customers to accept credit card numbers is Oracle doesn't have any standard procedures to actually purge the data. PCI has a requirement that says you shouldn't have credit card numbers over 18 months old. Well, Oracle doesn't provide any way to actually purge that data, and we run into numerous clients that have 10 years worth of credit card data online. Oracle PCI says you should be purging those credit card numbers. The problem is most people want to keep the orders, so you do have to develop custom procedures to actually go purge the credit card numbers but keep the order there, so it becomes challenging. You should be changing the encryption keys, so when you do a clone to test and development, you're actually copying the encryption keys most likely because you want to be able to at least access the data. So you have to have a procedure, and Oracle doesn't provide a real good way to actually have different keys in test and development and production and then try to scramble live credit card numbers. Another PCI requirement is you should have no live credit card numbers in your test and development. Well, now I've actually encrypted the data, so it's harder to get to, but I should be actually going in and scrambling all those credit card numbers. So a standard just flux state or update statement to scramble credit card numbers doesn't work when I'm doing cloning anymore. Now I have to do another step. And the Oracle data masking product doesn't do very well with this either. So you have to actually start writing some custom routines to get the data scrambled. So that's kind of an overview of the native encryption. We strongly recommend using native encryption versus using the solutions I'll talk about now. The native encryption is the strongest way to do it, the best way to do it. It's because it's at the application level. You can now control what responsibilities have access to the data and things like that. For certain columns, as we talked about, you can do credit card numbers and bank account numbers in R12. If I have Social Security numbers, there's no native way I can encrypt credit card numbers in tables like P or all people F table. That contains a national identifier field. Well, that has the Social Security numbers and sensitive data for other countries like UK, national insurance number in Canada, it's a social insurance number. So I need to protect those numbers. Well, at least I can have some level of protection by implementing a disk level encryption solution. And the one we recommend and most people implement is Oracle Transparent Data Encryption. It is an add-on feature, and it's actually fairly pricey. This is the one that works the best with Oracle E-Business Suite in our opinion. I don't ever like to highly tout and recommend a product, but there's a number of different ways to do this. TDE seems to be probably the best, but it is fairly expensive. But you should be looking at what your options are, what your disk SAN vendor supports. Metric is another option. So there's some other things you can do. I'll focus in on Oracle TDE because that seems to be what most people implement. But you should be looking at the other solutions, and they all work similarly. So Oracle TDE basically encrypts the data when you write it out to disk. When you read and write the data, it's encrypting it and decrypting it. You can actually do it two different ways. You can do it at a column level or a tablespace level. If you do encryption at a column level, there are a number of restrictions in what columns you can actually encrypt. For E-Business Suite sensitive data elements, we very seldom ever run into any problems encrypting specific columns using Oracle TDE. The constraints are usually related to really big columns, foreign key relationships, and the Oracle E-Business Suite data model that typically does not run, you don't run into that problem very often. So what does TDE actually do and not do? Well, it encrypts the data at rest. So TDE provides a lot of value if for very specific circumstances. So if I lose a disk drive, if I lose a database file, so the key for a database file is if someone hacks into my server and downloads the database files and then they can actually use a number of utilities that are available online to actually read those database files. You don't actually even have to mount those database files, have an Oracle database running. As long as I know they're an Oracle database file, I can actually read those and actually pull the data off. One of the other key ones is actually backup tapes of database files. So if any kind of backup tape for the database, the value will be encrypted in there. But once I sign on as an authenticated database user, it's transparent. I don't see any difference between the encrypted and unencrypted columns, table spaces. The issue we always walk into and think about is, does this actually satisfy the PCI requirements, the privacy requirements? Well, the value is encrypted, but if I get hacked and someone hacked into my database, used a default password or something like that, or basically used a security vulnerability and saw the data unencrypted, does that still meet the legal requirements for PCI, for some of the privacy regulations? And that's kind of a question that we can't answer. You probably need to walk through it and make sure your legal department understands that type of issue. So TDE provides some value, but it's not the end all. A lot of people will sell it doing much more than it really does, but it works well. There was actually a problem. I live in Chicago, and there was actually a news article in Chicago a couple of years ago that a couple of guys actually went into an office, cut a hole in the wall, knocked out the night manager, and basically stole a bunch of data servers. TDE actually covers you in that case. So you can actually have some protection from that capability, but not much more. There's column level and table space encryption within the eBusiness Suite for TDE. Our recommendation is actually to use column level encryption for standard EBS columns. So if you're looking to do national identifier for HR, PER, all people left table, we'd typically recommend use the column level encryption. It works well. It provides a lot of value there. For table space encryption, you should use table space encryption for your custom table spaces. And the reason for that is you could go through it and pick out on all your custom tables where you have sensitive data. But what happens when the next time a developer says, oh, I need to store Social Security number? Do you have a good enough change management process to go through and say, okay, yeah, we just added Social Security number, so now we have to add that actually into our encryption? If you encrypt the entire custom table space, you can control where those tables lie fairly easily, and you can encrypt the entire table space fairly easily. There's not a lot of performance overhead, and most often custom tables aren't the highest transactional volume tables. You're not hitting those tables massively, so any performance overhead at TDE probably would never be seen on a custom table. So it's very easy to do your entire custom table spaces. And so we strongly recommend, if you're going to use TDE, encrypt just the entire custom table space. Any custom tables you have, just encrypt them all, because you won't see much of a performance hit, and you'll actually capture all those data values. In terms of performance considerations, we typically don't see a significant performance hit. We actually talked with a recent customer who had encrypted their entire database using TDE for every table space, and they saw about less than a 5% performance hit. It was about 2 to 5% overall. There can be some specific cases where you actually see a larger performance hit on a specific column or on a very high transaction volume table. The problem with doing individual columns is you lose some of the capability to do indexing, and you end up doing some full table scans occasionally when you're doing one column. So that's typically where you see a hit. If you're doing table spaces and you actually own advanced compression option, if you actually use advanced compression, you can actually get a performance increase with that. And then what happens, Oracle compresses the data first and then encrypts it. So by doing the compression first, you're actually encrypting a lot less data. So if you do large table spaces or the entire database, if you run advanced compression option, you can actually get a large benefit there. But again, advanced compression option is an add-on cost feature. So that's the major methods to do encryption, both native encryption and standard database encryption. But as you saw, there weren't a lot of options for Social Security numbers. Oracle TDE is the best solution there. So that's why it's talking about data protection and things like that is important. The other type of encryption that we don't talk a lot about with customers, most people do the front end of it, but more people are now talking about database level encryption for the network traffic. So when we start talking about the standard EBS network communication, you basically have two communication points. You might have a whole bunch of different servers in this, but really there's two types of traffic that's flowing in your environment. There's the client browser to the EBS application server. And that may be internal to your network, or it might be external. So if you're running iModules like iStore, iSupplier, things like that, that traffic will actually be flowing across the internet. Then hopefully the application server to database traffic in your environment is within your data center. You're hopefully controlling that. You don't have your database server super far away from your application server. So those are the two basic types of traffic that we need to think about. And you might have a dozen servers in this environment, but the traffic communication between each of the different types of servers, you can really break down to one of these two types. So let's first talk about the client to application server traffic. You should be encrypting this. When we start talking about HTTP, when the client browser talks to the application server, all that data is unencrypted. So when they type in their user ID and password, that flows right across the network unencrypted. And someone can sniff on the network, they can capture those passwords, social security numbers, credit card numbers across the network fairly easily. On the internet, that's probably even more of a significant risk. Oracle supports very well SSL encryption. So you enable it on the application server, and then when the client connects, everything's automatically encrypted. We do recommend you strengthen the encryption settings. The standard out-of-the-box Oracle encryption settings are not weak, but they're not the best that they could be. You can definitely strengthen those. And there's a lot of different options within SSL. It's the different encryption methods and things like that, and you should be able to using fairly robust ones. That's how long the keys are and things like that. The Oracle notes give you a basic setup on how to do it, and then you should work with your IT security team because they'll have definite recommendations on what ciphers you should use, what length keys, and things like that. That's the native encryption within Oracle E-Business Suite. So Oracle supports enabling SSL directly on the application server. What most Oracle E-Business Suite implementations do is, if you're running more than one application server, almost always you'll be using a load balancer, reverse proxy, or some sort of device there to load balance between the application servers. You can actually use that load balancer also as an SSL termination point. So what happens is the client talks to the load balancer. At that point, you're using SSL, but between the load balancer and the application server, it flows unencrypted. The idea here is that unencrypted traffic is probably, hopefully, on the same switch locally within your data center. So the risk of someone actually intercepting that communication is fairly low. This is kind of the solution most people do because the load balancers are highly optimized devices. They can do the SSL encryption and decryption with very low CPU utilization. Where if you're using a large number of people on an EBS application server and doing the SSL there, you probably see a little bit of a CPU spike based on that. There's Oracle Metalink notes on how to support this. And also the advantage on the load balancer is you typically use the load balancer for quite a few different applications. If you buy a F5 big IP device, you might use it for 10 or 20 applications. That way you can centralize all the SSL maintenance, implementation onto one device. So that's typically the solution people use most often. The other piece of the puzzle is the application to the database server. What was interesting for this webinar is we typically don't talk about this. We get very few questions from our clients on how to enable this. For this webinar, we ask questions, if you have any questions. There's actually 3 or 4 people actually asked specifically about doing SQLnet encryption, so encrypting the traffic between the application server and the database server. Until recently, this was actually an add-on feature. So you actually had to buy the Oracle Advanced Security option to enable SQLnet encryption. With the release of 12c, and they backported this capability to 11g in terms of licensing, as of July 2013, the SQLnet encryption is no longer included with Advanced Security option. It's actually included with the base database license. So as of 6 months ago, this was a fairly expensive add-on because you had to buy Advanced Security option. Now it's included free. So if you want to do SQLnet encryption, it's actually pretty easy to implement. It doesn't have as real big CPU overhead, it's fairly easy to do, and you can actually get some benefit. The one area here is, if you look at things, some requirements, some customers say, well, we have to encrypt everything on our network. So if we have sensitive data flowing anywhere on our network, it has to be encrypted. So if you have one of those requirements, but like PCI does not require credit card numbers to be encrypted on your internal network. So for PCI, implementing SQL-Net encryption is not a requirement. But some organizations do have this as a requirement, that anytime sensitive data, passwords, key information like that is transferred, it should be encrypted. So that's kind of the high level on how to do SQL-Net encryption. Again, the MetaLink notes are here. This one is actually fairly easy to implement. You turn on a few options. The one additional feature here is you might have other people connecting to the database remotely. So the application server may be in the same data center as the database server, but you also might have some connections from other applications that may be in remote data centers. You might have some users directly connecting. This is where a big advantage of using SQL-Net encryption would be. A lot of customers who have that requirement and require it outside the data center to be encrypted, we actually used to recommend using 2 listeners. Based on modern CPUs and things, we don't see a lot of overhead, so if you want to enable SQL-Net encryption, we just recommend enabling it for all traffic nowadays. The performance overhead is fairly low. Most CPUs have built-in, within the CPU, encryption capabilities for AES, so most of that will be offloaded onto a specialized chip. So there's not really much of a performance overhead for modern servers anymore. So that's kind of a high level of how to do the application to database server traffic. And I was actually surprised there were some questions on this. We don't typically get that, but it's very doable now, especially that Oracle has released it. So that's kind of the high level on how to do the encryption at the different layers. This is an example here, this chart, where we do this often for our clients, that we walk through and talk about how are people accessing sensitive data and what are some of the threats in your environment. And if we start talking about using Oracle TDE, the native EBS encryption, you're not covered completely under every scenario. And so if someone actually signed onto the database for like social security numbers, and this also matters by data element, well, things aren't encrypted and you're not getting the best protection. So when we start talking about data protection and threats, there's actually a number of other things you need to be thinking about and doing in terms of access controls, auditing, as well as implementing. So like for social security numbers, we end up implementing TDE for a lot of our clients, but we also put in fine-grained access controls. We also turn on auditing to be able to capture who's actually accessing that data. So the TDE provides the encryption layer if I lose a backup tape or a database file, but then if someone signs onto the database, well, what happens if you have an outsourced DBA in India? They have full access to read all the data, or I actually have a lot of read-only users in my environment. They actually see the data unencrypted. So you can actually install different access control mechanisms like fine-grained access controls to actually limit access to those social security numbers and other national identifiers. So this is not an easy task. It's something that you really have to think about and design and go through and say, okay, yes, here's our capabilities for encryption. Here's each data element. Here's what we're going to do for each data element. And then try to map that to your threats and where you see the most risk. Some people trust their DBAs, other organizations don't. So that's kind of an outline of what the options are. Again, there's no complete encryption option with the e-business suite at this point. There's different things you can do and different elements you can encrypt, but a full encryption solution doesn't exist today. That is 100% robust and does everything you'd ever want it to do. And so what we'll do is open up to Q&A. We received quite a few questions, and I bet we have some more people have asked along the way.
Yes, we do. Thank you, Steve. The first question here is how to encrypt test systems but keep functionality fully operational.
One of the big challenges is when we're talking about cloning from test and develop, or cloning from production to test and development. Now that you're actually encrypting the data, you actually have to be rotating the keys and doing changes. That becomes a little bit of a challenge especially when you're saying, okay, I can't have the same keys in production, test, and development. So am I rotating the keys? Does the different solutions have that capability? So you actually have to rekey a lot of data typically in those type of scenarios. But it's very doable, but you do have to think about that as you enable encryption, especially on custom tables also becomes a challenge because your encryption is not using the standard native encryption, so you actually have a whole different key management issue there.
Next question. How to implement encryption for sensitive area and how it will impact the custom development and SQL access via.
So one of the big challenges, encryption works nicely, especially like the native encryption for Oracle eBusiness Suite. So now I've encrypted my credit card numbers, but a lot of clients actually then walk into a problem and say, well, I have these people using Discover, using OBIE, using Toad to actually access that data, and they need access to the credit card numbers. So when you actually go through your design, you actually have to look at all your data access patterns and who's accessing it. Because now if you're adding a layer of encryption, you may not have access to that data. So when Oracle implemented their credit card encryption, they actually had to go through every single form, web page, and report and program, concurrent manager program, and anytime they read or wrote a credit card number, they actually had to change the code. So a lot of different ways that you access the database today, if once you implement encryption, may not work. You may have no X views. You may have Discover running. Those, you have to kind of think through those. Do those people need access to the data? Can they see the data masked? So that becomes a challenge. And there is no easy solution until you walk through each of those scenarios. And that's the problem with encryption here. It's all, there's no easy silver bullet. There's no way to say, yep, this is going to work for every single situation, every single client. You have to walk through exactly which data elements you want to do, figure out who's accessing that data, and figure out if there's any ramifications to that. Because we see a lot of times that custom interface programs are trying to read and write those credit card numbers, and those stop working as soon as you implement credit card encryption. Hopefully you're using interface tables that handle that. But if you start doing direct reads on the credit card information to process it somewhere else, that becomes a problem and that stops working.
Next question. How about reporting tools such as Noetics that pulls data or information from Oracle?
And just as we're kind of talking about, is those and that's one advantage of TDE, but TDE doesn't provide you as much value, that TDE is transparent, that those tools would see it unencrypted. But as soon as you implement any sort of application level encryption or database level encryption in terms of views and triggers, those tools will not be able to see the data. To me, a lot of times, though, when you start talking about why they actually are using Social Security numbers or credit card numbers, that's not a very good business rationale. And so part of the problem is a business rationale of why someone needs access to a credit card number or Social Security number. Because as soon as you give them a tool to actually access that data directly, what's the first thing they're going to do is they're going to download a bunch of data down onto their laptop, and now you've got unencrypted Social Security numbers on a laptop. Then you lose the laptop, and then basically have to do a breach notification. So you should be minimizing that type of access, and just, do people really need that level of data? And typically they don't.
Next one, how about protecting non-production environments?
The biggest thing to do for non-production environments is scramble all the data. And usually the developers will push back, oh, we need full referential integrity. You don't need live Social Security numbers, especially in any test or development environment. For credit card numbers, you might need a valid credit card number, something that will actually check out, has the right identifiers to say it's a Visa number. But typically there, you don't even need a live credit card number. You can basically do routines when you do your scrambling to change those. So security numbers, we often use the identifiers in the tables. Seldom do we actually see a referential integrity between tables as required. But a lot of times they'll actually have the same identifier. So you get the ID values, and so you just start creating Social Security numbers based off of those ID values that are the row ID for that specific row, and that number can become pretty standard. Because Oracle usually does person ID or something like that, so that column would be typically in multiple tables, and you can just create the same social security number over and over and over. And same thing with bank account numbers. We actually recommend you change bank account numbers, especially scrambled, because a lot of times you don't want to be depositing tons of money accidentally. If you run something in the EFT process and actually runs and deposits money into thousands of people's bank accounts that you didn't mean, that becomes a huge crisis. But if you change the bank routing numbers to an invalid number fairly quickly in your process, then you know that's not going to happen. So actually it's a protection. It's not only to protect the data, it's to protect a mistake from happening, because most people don't have that set up, but there's times when it's happened before that people have deposited millions of dollars into different accounts accidentally from a test and development environment. It happens. And a lot of times the controls aren't good enough to prevent that from happening.
Next question. Is it better to stay with the Oracle solution, which costs a fortune, or look at third-party products?
We've had a number of clients implement TDE and have never had an issue. We've had clients that have looked at some of the third-party solutions and have had issues. Other ones have had great success. I know Oracle TDE works, but it is a fairly expensive proposition. When you get at the end of the day, I don't know how much of a price difference there is with some of the third-party solutions, but it's probably at least get quotes and understand what the different prices are, and work on a proof of concept. If you do want to implement a third-party product, I would definitely recommend before you buy it, have a proof of concept in one of your development environments to make sure it works, and run it in one of your development environments for a number of months, maybe 2 or 3 months, to make sure it works. You don't run into any significant problems. If you're running payroll, I'd make sure you run a payroll run. That's typically where those large volume processes is where you see a bottleneck and problems occurring. Also with the third-party solutions, key rotation is always a critical aspect of it. So some of those solutions actually provide better key management than Oracle does. Others don't. So when you look at an encryption solution, it's just not how the data is encrypted. It's not the performance. It's how you manage keys. It's how you manage the entire process. Can you use that for other places in the organization? Encryption is one of those solutions that just isn't enterprise savvy, enterprise ready today. You don't go buy one encryption solution and implement it everywhere in your enterprise. Big enterprises that have spent a lot of money implementing encryption, a lot of time and effort, have 6, 7, 12 different encryption solutions running within the organization. And that's the unfortunate part of where the encryption is today. It's solution by solution, database, files, email, key management. There's no great one solution there today. But when you're looking at third parties, definitely think about doing a proof of concept, looking at performance, but also looking at key management. When we do our assessments, we look at the key management process to make sure it's being done correctly, that the keys are being rotated, because typically you'll look at somebody who's been doing encryption for a couple of years, they've never rotated the keys. And if you're PCI, you need to be rotating those keys on a very periodic basis. How you manage those keys, are those backed up sent differently from the database? Those all factor into these discussions.
All right, thank you, Steve. I think that wraps it up for the day. Be sure to stay tuned for this next month. Our session will be on PCI DSS version 3.0, which is just introduced recently. That happens on January 23rd. So again, thanks for tuning in today, and have a great rest of the day.